Do you know ancient people looked at the sky and thought Earth was the center of the universe? It sure seemed that way under the vast, twinkling night sky. Just imagine, giant spinning spheres carrying the moon, sun, planets, and stars, all choreographed in a cosmic dance around our world. This was the prevailing view for centuries, championed by brilliant minds like Aristotle. But fast forward 1600 years and enter Newton, whose revolutionary law of gravitation shattered the Earth-centric illusion. And the cosmic journey didn't end there. Today, modern physics, shaped by Einstein's mind-bending theories, propels us into the depths of space-time, challenging and expanding our understanding of the universe in ways no ancient astronomer could have dreamed. Welcome to Explore the Curiosity, where we embark on a thrilling voyage through time. From the dawn of human wonder to the cutting edge of modern physics, we'll trace the ever-evolving tapestry of our cosmic comprehension. In the dawn of human history, before the first ink scrawled a story on papyrus, our ancestors gazed at the cosmos with wide-eyed wonder. The tapestry of stars above wasn't just a spectacle. It was their calendar, their clock, their whispered stories of creation. Unlike us, burdened by screens and city lights, their nights were plunged into a celestial symphony. The sun, moon, and planets playing their silent dance across the velvety sky. These early humans, keen observers of the heavens, saw patterns we might miss. The sun's fiery chariot blazed a daily trail, dictating their rhythm of life. The moon, a celestial storyteller, spun tales of light and shadow, influencing tides and weaving dreams. Their curiosity wasn't just whispered in the wind. We find echoes of their wonder in the silent halls of prehistoric caves, where star clusters dance on painted walls and phases of the moon leave their luminous trace. Like ancient storytellers, they etched celestial whispers in stone. Megalithic monuments like Stonehenge aligning with the cosmic ballet above, marking seasons and celestial ceremonies. Animism, the belief that everything held a spirit, infused their world. The sun, moon, and stars weren't just celestial bodies. They were living entities, woven into the fabric of their existence. Rituals and practices intertwined with the heavens, appeasing celestial spirits and seeking answers in the starlit tapestry. Though their understanding of the universe differed from ours, their cosmic curiosity blazed with a primal fire. They were the first astronomers, the first to whisper theories into the darkness, their knowledge passed down through generations in stories whispered around crackling fires. Their journey laid the foundation for our own, paving the way for telescopes and spaceships, for questions whispered not just under the night sky, but echoing through the universe itself. So remember, the next time you gaze at the stars, you gaze not just at the cosmos, but at a legacy. A legacy born in the wonder of prehistoric nights, etched in stone, painted on cave walls, and passed down through generations. We are the inheritors of their starry-eyed curiosity, forever seeking answers in the cosmic canvas above. Imagine a time before telescopes and spaceships, when the night sky was a dazzling mystery. This is the Middle Ages, where towering cathedrals pointed fingers at the heavens, and scholars hunched over ancient scrolls trying to understand the universe. Back then, most folks believed the Earth was the center of everything. Planets and stars danced around it, like planets on a merry-go-round. This idea, called the geocentric model, came from ancient thinkers like Aristotle and Ptolemy, and it fit nicely with the religious beliefs of the time. It made humans seem pretty important, right in the middle of God's grand creation. But things weren't quite so simple. Scholars started noticing things that didn't quite add up with the geocentric model. Stars and planets didn't always move in perfect circles, and some observations just didn't fit the puzzle. This wasn't just a scientific curiosity, it challenged the whole understanding of our place in the universe. Thinkers like Thomas Aquinas tried to bridge the gap between faith and reason. They believed that God created a perfect universe, but that we could still learn about it through observation and study. This paved the way for a future where science and religion could coexist. Even though they might not always agree on everything, science, though, wasn't quite the powerhouse it is today. Back then, people relied more on ancient texts and philosophical reasoning than experiments and data. This slowed down the pace of discovery, but it didn't stop it entirely. Astronomers like Regiomontanus built clever instruments and recorded their observations, laying the groundwork for future breakthroughs. Slowly but surely, the cracks in the geocentric model started to widen. New ideas emerged, like the sun being at the center and the universe being much bigger than anyone ever imagined. It was like a new map of the world was being drawn, with the Earth no longer at the center, but just another planet in a vast and mysterious cosmos. Thinkers like Copernicus, armed with precise calculations and celestial observations, dared to unseat Earth from its cosmic throne. His heliocentric model, placing the sun at the center of the solar system, sent shockwaves through the established order. But without tools to validate his theories, it remained a hushed whisper in the celestial wind. Then came Galileo Galilei, his finger pointed not at scripture, but at the heavens. His telescope, a revolutionary lens crafted with improved glass-making techniques, pierced the veil of obscurity. Mountains on the moon, moons orbiting Jupiter, and phases of Venus all contradicted the perfection and immutability of the celestial spheres. These weren't just celestial curiosities. They were cracks in the geocentric foundation, threatening to unleash a torrent of new understanding. But the Church, a powerful protector of tradition, clung to the old paradigm. Galileo's revelations were met with resistance, forcing him to recant his heresies under threat of persecution. Yet the seeds of doubt were sown. His observations, meticulously recorded thanks to the advancements in printing press, echoed across Europe, fueling the flames of scientific inquiry. In the midst of this intellectual upheaval, Johannes Kepler emerged as a cosmic cartographer, charting new territories in the realm of celestial mechanics. Building upon the foundations laid by Copernicus, Kepler's brilliant mind refined the orbits of planets, introducing a mathematical precision that harmonized with the grand celestial ballet. His 3 laws of planetary motion, unveiled in the early 17th century, became the guiding principles that unlocked the secrets of the cosmos. Kepler's contributions transformed the way we perceive the heavens, imprinting his name alongside the giants of the scientific revolution. Meanwhile, as navigators traversed uncharted seas armed with improved tools and guided by advances in mathematics, curiosity about the celestial sphere intensified. Scientific instruments, such as the sextant and astrolabe, transcended their role in navigation, becoming probes into the intricate clockwork of the cosmos. This era marked a convergence of exploration and understanding, where the cosmic mysteries above were illuminated by both navigational and scientific ingenuity. The seeds of change sown in the Renaissance found fertile ground during the scientific revolution. Telescopes became cosmic windows, unveiling hitherto unseen celestial secrets. Printing presses disseminated knowledge with unprecedented speed, and mathematicians armed with newfound insights deciphered the cosmic code. This revolution rippled not only through the lives of luminaries like Galileo, but also through the very fabric of human understanding, forever altering our perception of the universe. Remember the geocentric model, Earth at the center, a cosmic stage play with flaws in the script? The Middle Ages cherished this script, but whispers of doubt, carried by knowledge preserved. And ideas reborn echoed across the Renaissance. Questioning was no longer heresy, it was the engine of progress. One man, Isaac Newton, dared to rewrite the script entirely. He peered into the heavens and saw not celestial clockwork, but the dance of gravity. His laws of motion, precise and universal, dethroned Earth and embraced a universe governed by elegant, predictable forces. Gravity, the invisible hand pulling planets and apples alike, became the star of the show. Newton's revolution wasn't just about celestial bodies, it was about unifying the heavens and earth under one set of laws. The whisperings of the Middle Ages, the breakthroughs of the Renaissance, all culminated in this grand cosmic rewrite. This wasn't just a new script, it was a fresh page in the story of humanity. The day we unraveled the secrets of motion and etched them onto the very fabric of the universe. Before we blast off into the modern cosmos in part 2 of the video, and explore how Newton's gravity, Einstein's space-time, and modern discoveries redefined our understanding of the universe. Let's take a detour through time. What did our ancestors think the heavens were made of? What myths and mysteries surrounded the stars in the prehistoric and medieval eras? Share your thoughts in the comments below. Don't forget to smash that like button to fuel our cosmic journey. And subscribe to join us for more mind-bending explorations of the universe. Buckle up, because in part 2, things are about to get seriously out of this world.